Hello students, welcome to my YouTube channel. In this video lecture, I am going to solve 10 questions which are suitable for ATPL exam. So these questions often get asked in ATPL exam, and these sums are for general navigation paper. So make sure you solve all these questions and also watch my previous video lectures in which I have solved other general navigation questions. So let's start. This will be question 21. Two coordinates are given. You have to find great circle track A to B, B to A. So let's plot this. We are in the southern hemisphere. Pay attention to the latitude in the east and in the west. So A is here, B is here, A is 30 south, 20 east, B is 30 south, 20 west. Right? Now we have to find great circle track. Now you can see that both coordinates, both the positions are on the same latitude or are on the same latitude. That means line tracks will be oriented east-west direction, east and west direction. So line track Bravo to Alpha B to A will be 270, considering this your north direction, that will be east, south, and that will be west. So coming from B to A, you will be following a direction of 090, correction. You will be following a direction of 090, and coming from A to B, going from A to B, you will fly 270. So this is 090 and this is 270. Now to find great circle track, we must know convergency angle. What is convergency angle? Convergency angle is nothing but half of convergency. What is convergency? D long in degree into sine lat. What is D long? 20 west, 20 east is 40 degree. Sine 30. Sine 30 is half. So convergency is 20 degree. Convergency angle will be half of that, that is 10 degree. Great circle A to B will be this much. That will be rhumb line A to B. The rhumb line is the bigger angle, this much. So we will have to subtract the bigger angle, convergency angle, from this bigger angle. Rhumb line A to B minus convergency angle. 270 minus 10, 260. And great circle B to A will be this rhumb line B to A plus convergency angle. So rhumb line plus convergency angle. (100°). So answer is 260 and 100. Isogonal lines converge where? So remember, isogonal lines converge at north and south poles, and these poles are magnetic north and south pole as well as true north and south pole. So you will find this fact 3, chapter number 3, page number 50. Isogonals converge on both true and magnetic north and south pole. Question 23. VLE. What is VLE? So VLE is landing gear extension speed. That means This is the speed at which you will you can fly maximum speed at which you can fly your aircraft with landing gear down. So that means your landing gear is positioned down, it's down and locked, and you can fly this aircraft with your landing gear hanging down. Contrary to this, VLO, this is landing gear operating speed. What is landing gear operating speed? It is the maximum speed, okay, speed at which you will operate your landing gear. That means you are coming down for descent, approach, landing. So during your approach phase, you will decide to lower your landing gear from the fuselage. The landing gear will be positioned inside your fuselage. So once you are conducting your approach and the right time comes to extend this landing gear outside, you will operate this landing gear. So operation of landing gear means extending that landing gear during the landing phase of your aircraft, or retracting, that means uh, uh, positioning that landing gear in your belly of aircraft or fuselage when you have taken off and you are airborne. So this is called operating landing gear, extending or retracting. And landing gear extension speed is flying this aircraft with landing gear extended. Okay. Next, task is given, endurance is given, wind component is 50 knots headwind outbound. What is distance to PNR and time to PNR? A to B, there is point of no return here. Okay, you're flying outbound, as is 300 knots. You are getting a headwind of 50 knots. Going outbound, you will get a headwind of 50 knots. So your ground speed will be 300 minus 50, 250. Coming homebound, flying back home, task is again 300, and now this wind component will serve as a tailwind of 50 knots. So your ground speed will be 300 plus 50, that is 350 knots. Distance to PNR is endurance into outbound speed into homebound speed divided by outbound plus homebound. What is endurance? It is 10 hours. Outbound speed 250, homebound speed 350 divided by 250 plus 350 divided by 250 plus 350. Now 250 plus 350 is 600. 250 into 350 into 10 is 875 divided by 600, that is 1458 nautical miles. So time to PNR will be distance to PNR divided by outbound speed 1458 divided by 250, that is equal to 5 hours 50 minutes. 5 hours 50 minutes. Simple. Next. Dip is 0 at what latitude? Very important question. Now dip is the angle between horizontal component of the Earth magnetic field and the vertical component of the Earth magnetic field. Okay. So dip is the angle between them. Okay, dip is the angle between horizontal and vertical component of the Earth magnetic field. Now on the Earth, let's say this is your equator, and this is your north pole, and this is your south pole, correct? Now, at the equator of the earth, the horizontal component of the earth magnetic field is maximum, and vertical component of the earth magnetic field is minimum, 0. At poles, vertical component of the earth magnetic field is maximum, horizontal component of the earth magnetic field is minimum. Okay, so opposite happens at the pole. Anywhere between the magnetic equator and the poles, north pole, south pole, whatever, your horizontal component and vertical component will differ, okay, more or less. So as you go away from the magnetic equator towards the pole, okay, when you go away towards the pole, vertical component Z increases, horizontal component H decreases. When you come down towards the equator, horizontal component H increases, horizontal component H increases. Okay, so as you go from equator to the pole or pole to the equator, there will be some angle between vertical component and the horizontal component. At equator, the angle will be 0 because you only have horizontal component. At poles, again, the angle will be again 0 because again you have only vertical component. Between these two latitudes, you will have different angles. So angle of dip is 0 at magnetic equator. At magnetic equator, where you do not have vertical component of the earth magnetic field, you only have horizontal component. Okay, so dip is 0 at magnetic equator. Next, alpha and bravo is given. Again, we have to find great circle track. This is similar to the question number 21 previous that we did previously. So let's draw this. It's in the southern hemisphere. Alpha, bravo, 70 south, 60 east, 70 south, 30 west. So both are located at same latitudes. Rumline, great circle. Both are located at same latitude. That means Rumline track A to B, Rumline track A to B will be 090. Same latitude. So latitude is oriented east and west direction. Rumline B to A is 270. Supposing this is your north datum. Okay. Now convergency. Convergency is D long in degrees into sine latitude. Now D log, difference between 30 west and 60 east is 90 degree, sine of 70. So 90 into sine 70 is 84.5. Okay, let's consider 85 degree. So convergency angle will be half of that, that is 42. Let's consider 85 is 84. Okay, 42 degree. So convergency angle is 42. 42. Rumline A to B is 090. Rumline B to A is 270. Next, great circle A to B will be Rumline A to B plus convergency angle. Rumline plus convergency angle. So 090 plus 42. 90 plus 42 is 132. Great circle B to A will be Rumline minus convergency angle. So in case of B to A, Rumline is the bigger angle. From that big angle, you will have to subtract this convergency angle in order to get this great circle track. So 270 minus 42.